Welcome to our brand new chapter. We will begin trigonometry. Our first objective in this tutorial is to graph angles in degrees and radians. So we are in section 5.1 of our textbooks, and we will begin trigonometry. Trigonometry is one of the ometries in math. Trigonometry is the study of triangles. Mathematicians first used trigonometry to explore the geometric shape of the triangle. It wasn't actually until about the 17th century where mathematicians really expanded the use of trigonometry and started to see the trig values as trig functions. And that's where our exploration is actually going to be in this chapter. We started to see trigonometry as the use of functions, light and sound waves, orbits. Okay, how about that? And various other applications. So that was around the 17th century that we did that. Where we're going to begin is graphing angles. And I want to make sure that everybody knows how to graph our angles in standard form, standard position. An angle graphed in standard position will always have the vertex at the origin. So the vertex will always be right at the origin. And what we call the initial side will always be the positive part of the x-axis. So that's where all of our angles will begin. Vertex at the origin, initial side on the positive part of the x-axis. Then our angles will either open in a positive direction, that's upward, or a negative direction, that would be downward. So it's going to be real important for you to indicate which direction we're opening. In this angle, I'm just going to open it upward, so it'll be a nice little acute positive angle. We like to label it with one of our Greek letters. I'm going to choose alpha. Some of my go-tos, I like alpha, I like capital beta, I like theta. There are 24 Greek letters that we could use, capital letters and lowercase letters. I tend to use these three. Again, this is alpha, kind of looks like a little fish guy. Beta is basically a capital B, but it's just a little elongated tail. And theta is not the null set symbol. This is a horizontal little belt through our zero-looking thing. That's called theta. Okay, so our angle will, in this case, will open upward, and then this will be our terminal side. The terminal side is where the angle ends, terminal meaning ending. So that's our terminal side. So angles graphed in standard position at the vertex is the origin, and the initial side will always be the positive part of the x-axis, and then we will label with the direction of opening with a little arrow, and we'll label our Greek letter. So let's talk about the two different ways that we will measure our angles. In geometry, of course, you used degrees. And you know that if you start there on the x-axis and go one full revolution all the way around once, then you've gone exactly 360 degrees. Degrees should not be a problem for you since you've been using them. You should be able to break the 360 degrees up into, halfway is 180 degrees and a quarter of the way is 90 degrees, and you should be able to estimate where any angle is. What we're going to be weaning you off of degrees and onto is the radians. Radians is a new way that we will learn to measure an angle. Degrees is, you could take a protractor and measure the degree of this angle. It's actually the degree of opening. Maybe this is a 30-degree opening or 37-degree opening. What radians measures the actual distance that you're traveling along the circumference of a circle. That's what radians is, or radians are. The measure of radians, if we start here and we go one full revolution around, we are going exactly 2 pi radians. So one full circle is measured as 2 pi radians. Now I'm using this symbol up here in the superscript, this little r. We very rarely use this. What we do is whenever we're talking about an angle in degrees, we definitely use our degree symbol, and when we don't see a degree symbol, then it's implied that we're talking about radians. So it's very important for you to use a degree symbol everywhere you mean an angle in degrees. So this is where we're going to start to really focus, and I need to get you to the radians idea very soon. So if the whole thing is 2 pi, pi, then we could go 1/2 of that, which would be 1 pi, and 1/4 of that, which would be 1/2 of a pi, and so on and so forth. So we'll practice with that. And don't worry right now if all of this looks Greek to you, because indeed that is who came up with all of this stuff. Okay, so we'll practice that. I'd like to end the tutorial right here with these 6 problems. I'd like to graph each of these. 3 of them are measured in degrees, and 3 of them are measured in radians. So let's do that. These are just sketches, so I'm just going to do a quick little set of axes here. The first one is measured in degrees, and we're talking about 300 degrees. We always know that we're starting with the vertex at the origin, and the positive part of the x-axis will be where the angle begins. That's the initial side. Since we're talking about a positive angle, we're opening in the positive direction. Now we need to know how far we're actually going. Well, the entire circle is 360 degrees, so that's too much. 90 degrees, too little. 180 degrees, still too little. Add another 90 degrees to 180 and we're at 270 degrees, which is almost there. So we're 30 degrees into the 4th quadrant. So we should be a little bit closer to the y-axis part of the 4th quadrant than the x-axis. Now, if we just stopped there, nobody really knows which angle we've just graphed. That's why we have to have our arrow so people know that we opened that direction and we went all the way 300 degrees, approximately. It's just a sketch. We should label our angles with a theta, well, in this case, a theta. So somewhere along that opening arrow is where I put my little label. And the directions say, let's name the quadrant where our terminal side is. This is quadrant 1, and then 2, and then 3, and then 4, but we use our Roman numerals because they were the ones who invented the names of the quadrants, and Roman numeral for 4 is IV. So our terminal side ended in quadrant 4. Let's try one that's measured in radians. I know that this angle is measured in radians because I do not see a degree symbol. If I see a degree symbol, we're in degrees. If not, I know that we're in radians. Usually the pi is going to be in radians, but don't always think that just because you see pi, it must be in radians, because I could easily ask you to graph an angle of 15 pi degrees. That might be confusing, but you could figure that out. It's about 45, 48 something degrees. Okay. So 5 pi over 6 we need to graph. Okay, so that's positive as well. So I know that I'm opening in the positive direction, but now I need to figure out what part of the pi. All the way around is 2 pi, so obviously that's too far. If I go halfway, that's 1 pi. And this is an angle that's less than 1 pi because it's 5/6. 6/6 would get us all the way here, 1 pi. So 5/6 is just going to be a little bit short. So I'm going to approximate that we're about right there. I'm saying to everybody that I'm opening in the positive direction, so I'm going to have my little arrow starting on the positive part of the x-axis and opening to my terminal side. And since this is a little alpha, I'm going to label it with an alpha. Now, what I did not do in this problem that I did do here, I didn't actually put a dot on the vertex, or for the vertex, and I didn't draw the initial side. That's okay. If you want to do that, that's great. It probably looks better. If you don't, every mathematician knows that you're going to be graphing it in standard position, so we know that it's always going to be starting here. Most people just put the terminal side, and that is fine with me as well. Let's name the quadrant. This is I, and this is II. So we're in quadrant 2. We use our Roman numerals. See? Let's go ahead and graph one of these. This is now a negative angle. I'm going to change color. It's a negative angle. It's measured in degrees. I know that I'm going to be opening downward. Maybe this time I do my vertex and my initial side. That's completely up to you. But I do know that I'm traveling in the negative distance this time, in the negative angle. So if I go this way, I'm negative 90 degrees. And if I keep going to here, I'm negative 180 degrees. It's obviously too much. Negative 135 actually is right down the middle of my 3rd quadrant. Again, I need to open it in the direction that I'm supposed to be opening, and this is a capital beta, so I'm going to do that with a longer tail. This is quadrant 3, negative 135 degrees. Let's graph 3 more. Let's go over here to part D. This is another radian angle, and this one is going to be measured in or is a negative angle, I'm going to put my vertex and my initial side here. And since I know I'm traveling in the negative distance, I know I'm going this way. Now, negative pi over 4, negative pi over 2 is right here. So that negative pi over 4 must be exactly in the middle of that, and here we are, right in the middle of the fourth quadrant. We're going to open down this way, and I'm labeling it with my theta. And I know that that's quadrant 4. I've already been there before. So there's negative pi over 4, approximately. Let's go to 200 degrees. We're back to a positive angle. 200 degrees is, I'm opening in the positive. I know that this is 90 degrees. And I know that this is 180 degrees. That's just not far enough. So I know that I'm going a little bit into the third quadrant. And in fact, I know that it's exactly 20 degrees into the third quadrant. I'm going to approximate it right about there. Open up to there. And this is a beta. So I'm going to put a beta right here. Quadrant 3 we haven't named yet, but quadrant 3 has 3 little eyes. I. And finally, our last one. Hopefully you're getting the hang of this. We're going to practice this more in class. This is another radian angle. This time it's positive, so I know I'm going in the positive direction. 7 pi over 4. Well, that's very close to 8 pi over 4. And I know that 8 pi over 4 is exactly 2 pi. And 2 pi is my full circle. So I'm very close to going all the way around. This is 1 pi over 4, this is 2 pi over 4, this is 3 pi over 4, this is 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4 is right there in the middle of our fourth quadrant. If I want to get some color in here, there we go. Now I need to know that I've opened this way. So I'm drawing that, and what is this, alpha? So I'll put a little alpha here. And that's, again, quadrant 4. That's the end of this tutorial. Right now you should be able to graph angles from radians or from degrees, and of course do all of the labels. Thanks for watching.